Uh, Now we will discuss the differentiation of hyperbolic function. But before discussing the differentiation of the hyperbolic function, we must familiar with the some expression uh, of hyperbolic function, that is sine hyperbolic x is equal to e exponential of x e minus x divided by 2, while cos hyperbolic x is equal to Ex plus E minus x divided by 2. So now by using these formulas, uh, we may calculate the derivative of first exercise is sine derivative of sine hyperbolic x. What is that? Okay. So to find the solution, let so as we know that sine hyperbolic uh, x is equal to ex minus e minus x divided by 2. So when we as we know that derivative of sine hyperbolic x with respect to x will be, as 1 by 2 is a constant number, and we know that from the f c d by dx, as we have now that that will be equal, constant will become out, and that will become a derivative of this. So similarly for this exercise, 1 by 2 is constant, so it will be come out, and remaining the derivative will be applied on ex dx minus de minus x over x. Okay, so as we know that the exponential derivative is the same. We have already derived it and we have already proved it. So ex derivative will be and dx over dx, that will be a 1 minus the derivative of e minus x will be also a minus x, and derivative of d minus x divided by dx. And that will be and when we divide dx over with respect to dx, that will be equal to 1, because x is divided with, and that will be equal to because this will be equal to minus dx over dx, and that will be equal to minus 1. Okay, I may say that that will be equal to, because this is this, so this will be equal to minus 1. So in this way we will get final result, that will be a 1 by 2 uh, ex minus minus because that is a minus 1 minus minus plus e minus x divided by 2. And but this is sorry, not 2, because I have taken the common 2, already taken common, and this is ex minus ex plus 2, sorry, ex plus e minus x divided by 2, that is according to formula, that is equal to cos hyperbolic. So the result will be a answer will be a cos hyperbolic x. So from here we have proved that this derivative of sine hyperbolic is equal to cos hyperbolic x. So similarly similarly uh, now we will find sometime it okay, now next is derivative of Next exercise is what is the derivative of cos hyperbolic x, and we will prove that that will be a sine hyperbolic x. Um, Actually, the derivative of cos x is minus sine x, but in the case of hyperbolic, the result will remain, there will be a no negative sign. But in the case of hyperbolic function, the derivative of cos hyperbolic is a sine hyperbolic. Okay, so now I will try to prove to solve it. A solution. What is the solution of? So let So, derivative of, firstly, we will write the expression of cos hyperbolic x in the form of exponential. As we have done already, that will be ex plus e minus x divided by 2. As we have done already, 1 by 2 is constant, so it will be come out from the uh, derivative sign, and because I have already explained as in this case. Okay. So the same formula will be applied here. So d by dx will be applied. D by dx will be applied on d dx and plus d by e minus x over dx. Okay. So derivative of as I have already explained, derivative of dx plus e minus x, that will be a t minus x divided by tx, and that will be equal to, as in the previous case, v minus x. As in the case of previous, I have already defined that that will be a minus dx over dx, and that will be equal to minus 1. So what will be the answer? So answer will be 1 by 2 ex minus e minus x due to this minus 1 2, and this will be a 1 by 2 sorry, this will be a sorry, if we, here is not 2, you may write ex minus e minus x divided by 2. So that will be actually the sine hyperbolic x. So as I have already explained, the cos hyperbolic x over dx, that will be your required result. Okay. So the derivative of cos hyperbolic x will be a sine hyperbolic x. Now the question is, next exercise is to find the derivative of d by dx. Next exercise is find the derivative of tan hyperbolic x dx. What is that? And so as we know that tan is sine hyperbolic x divided by cos hyperbolic x, and by applying the quotient theorem, which is first quotient theorem is, if you are, what is the quotient theorem? If two functions are dividing, then first function, derivative of first function multiply by second function minus first function as it, derivative of second function divided by square of the denominator. Okay. So similarly, we will be apply the same formula here. That will be equal to derivative of derivative of sine hyperbolic. That will be so derivative of sine is cos hyperbolic x, and multiply with the cos hyperbolic x. Denominator is cos, that's why gx is a denominator, so that's why that will be equal to this. Okay, minus, so the minus the fx is a sine hyperbolic x. The derivative of cos is also a sine. I have already proved that there is no sign change. So and square of the cos hyperbolic square x. So so the result is uh, cos hyperbolic square x minus sine hyperbolic square x divided by 2, and this cos square and sine, this is equal to 1. This is a formula. Okay, so sorry, this is not a 2, this is a cos cos hyperbolic square x. Okay, so 1 divided by, so answer will be 1 divided by cos hyperbolic square x. But hyperbolic square x. But cos का hyperbolic square is equal to uh, secant square. Cos inverse of cos is secant square. So the what will be the result? D tan hyperbolic x dx will be uh, secant secant square hyperbolic x. So this will be your required result. Okay. Now the question is, next exercise is about 10. Next exercise about the cot. Exercise is what is about the d by d cot hyperbolic. I must write again. So d by dx cot hyperbolic x. What is the that? So from the solution, solution. As we know that cot is cos hyperbolic x divided by sine hyperbolic x. The same as we have done in the previous exercise. Derivative of cos hyperbolic is sine hyperbolic x. Derivative sine hyperbolic will be as it. Denominator will be as it. Here then the derivative of nominator will be as it, and derivative of denominator there will be no change. Always keep in mind in hyperbolic function, sine hyperbolic is cos hyperbolic and cos hyperbolic is sine hyperbolic. There will be no sine inversion. Okay, so that will be equal to sorry here, so that divided by the square of the denominator, that is square x. Okay, but as we have already explained that cos hyperbolic square and sine hyperbolic square is equal to 1. So in this way, we have to consider, we have to take minus common, and the remaining will become cos hyperbolic square x, plus will become a minus, and minus will become a sine when we take the negative sign as a common. Okay. Okay, cos hyperbolic minus sine square hyperbolic x divided by sine hyperbolic square x. As this, as I have already explained, that this is equal to numerator is equal to 1. So the result will be equal to minus 1 divided by sine hyperbolic square. Sine hyperbolic square x. But the inverse of sine is, as we know that inverse of sine is a cosecant hyperbolic, cosecant square hyperbolic x. So from here, d by dx cot hyperbolic x will be equal to negative cosecant square hyperbolic x. So this will be your result. And the next exercise is about the secant. So next exercise is what is the derivative of secant hyperbolic x. Okay, so what is that? To find this, as we know that cosecant is secant is inverse of cos. Right, take a solution. D by d. This is d by dx, not d by dt. The cosecant is 1 over cos hyperbolic x. So I may say that d by dx cos hyperbolic minus 1x. By using the power formula, firstly power will be shift, that will be a minus cosecant hyperbolic minus 1 will be equal to minus 2x. Okay, and the derivative of cos hyperbolic x dx, that is equal to, so our result will be minus cos hyperbolic square x. The derivative of cos is sine hyperbolic x. Okay, so result will be here is a minus 2, so it will be because here is a minus 2, so it will become down, so the result will become 1 over minus cos hyperbolic x, and we may write as sine hyperbolic x divided by cos hyperbolic x. As we know that sine and 1 by cos is secant hyperbolic x, secant hyperbolic x. Sine and cos is equal to sine, and this sine is equal to tan hyperbolic x. So that will be sorry. That will be tan hyperbolic x. So So I may say, I may write so may I write result that is about the result is d by dx of secant hyperbolic x is equal to minus secant hyperbolic x tan hyperbolic x. This formula is different than the simple secant because simple secant derivative is secant x tan x, not a cosecant x. Okay, but in this case, negative sign will be appear. Okay, that is there is a difference of sign. Okay, in secant hyperbolic x, there will be minus sign, but in simple secant x, there will be a no sign, no negative sign. Okay, next next exercise is about the next exercise is d by dx of cosecant hyperbolic x. What is that? Okay. So now we will prove. Now we will try to find the solution of this. So let's start. The cosecant is equal to the secant is 1 divided by cos and cosecant is 1 divided by sine. So derivative d by dx will be 1 divided by 1 divided by this is cosecant, so 1 divided by sine hyperbolic x. The same as I have done in the previous exercise, there will be a sine minus 1 hyperbolic x and power will be shift. So that will be a minus sine and power will be minus 2 sine hyperbolic x. And the derivative of sine hyperbolic x dx. The derivative of sine hyperbolic is cos x. So that will be a minus 1 by cos hyperbolic square x. Derivative of this is cos hyperbolic x. Okay. Derivative of sine is cos hyperbolic. So minus 1 by cos hyperbolic x. Oh, sorry, not cos. This is a 1 over, sorry, this was a 1 minus sine hyperbolic square x. Okay. So we have minus 1 over, so we may write it in this way, hyperbolic x cos hyperbolic x divided by sine hyperbolic x. 1 over this is equal to cosecant hyperbolic x and this is equal to cot hyperbolic x. So so the result will be minus cosecant hyperbolic x cos and sine. When we divide the cos with the sine, that will be cot hyperbolic x. So at the end, finally, we will get the sorry. The cosecant hyperbolic x is so what will be the result? So d by 1 minute. Sorry, here is some problem. So derivative of cosecant hyperbolic x with respect to x is equal to minus cosecant hyperbolic x, cot hyperbolic x. So this will be the your required result. For today, it is enough. Okay, so these are the derivative for cosecant, that cosecant hyperbolic, that will be cosecant hyperbolic minus cot x. Okay, for secant, that will be a minus secant hyperbolic minus secant hyperbolic tan hyperbolic x. Cot hyperbolic is minus cosecant square hyperbolic. Tan is secant square hyperbolic x. And sine cos hyperbolic is sine, and sine is I must write the derivative of I must also mention here that derivative of sine hyperbolic x is equal to cos hyperbolic x. So these are the result. Okay. Uh, so all are these are about the uh, derivative of hyperbolic functions. Okay. So